Hi, welcome back. This is Professor Ridge, and today's lesson is on the Review Chapter Section 6, Rational Expressions. So a rational expression is the quotient of two polynomials. For example, you can have something simple as a fraction, because basically two constant polynomials, so like 8/13. It could be something like 5 over x squared plus 2x plus 7. Okay, so those are rational expressions. X cubed minus 8x plus 1, x squared plus 5. Okay, so those are all rational expressions. The domain of an algebraic expression is the set of all real numbers for which the expression is defined. Okay, so if we note, since any number divided by 0 is undefined, for rational expressions, anything that would make the denominator equal to 0 has to be thrown out of the domain. Alright, so let's check this out. Okay, so what you do is just take the denominator, set it equal to 0, and solve to determine what's not in the domain. So x can't be 3. Alright, so it can't be in the domain. Okay, it's not allowed. So the domain is everything but 3. So we'll go negative infinity to 3, union 3 to infinity. Alright? If you had an expression like this, say x squared plus 3x plus 2. So again, what you do is you let the denominator equal to 0, solve it to determine what's not in the domain. So factors of 2 that equal to 3, 2 and 1. Signs are both positive. Set each of those equal to 0. So x is negative 1 or x is negative 2. Oh, we want domain. So the domain is basically everything but those values. So negative infinity to negative 2, negative 2 to negative 1, union negative 1 to infinity. Alright, so that's domain. Okay, so next we're going to review how to multiply rational expressions and simplify. So the key to this is you just factor everything. So you just got to remember you factor. So we just factor everything. So if x 12, that subtract to 1, so that's 4 and 3. Put in the signs. On the bottom, factors 8, they add to 6. So let's see, 4 and 2. Bigger one's negative, signs are the same. And then for the second fraction, factor 6, that subtract the 1. Well, these are a's. Plus 3 and 2. Plus minus. Factor 24, that subtract to 2. 6 and 4. Minus, plus. Okay, and then you cancel common factors, one on top for one on bottom. And you can think of this as one big fraction. Same thing. So let's see, I have a minus 4, a minus 2. So that's it. So what's left is the a plus 3 squared on top, and then the a minus 6 times the a plus 4 on bottom. So that's simplified. Technically, you know, it's not simplified because we'd have to multiply everything out, but typically with rational expressions we leave it in the factored form, and we call that simplified. Even what we really mean is reduce. It's reduced. Okay, so to divide rational expressions, oops, should have been divide. What you do is you change divide to times, and you flip that second fraction, or the fraction immediately following the division. Remember, divide is multiplied by the reciprocal. So we flip that one over. And we got x squared plus xy plus y squared. First one we leave alone. Okay, now we're going to start factoring everything. So difference of squares, x plus y, x minus y. X squared plus 2xy plus y squared, well, that's x plus y squared. I'll just write it factored out. And then on the bottom, we got a difference of cubes. So that's x minus y. We square the first term. Multiply them together. So let's see, that's xy change the sign, plus y squared. Then we got x squared plus xy plus y squared. And then we cancel one on top for bottom, and I end up with x plus y cubed over x squared plus xy plus y squared squared. Okay? So that's dividing. Now for adding and subtracting, let's try. So the key is we have to have common denominators. So if I had something like 12 over a plus 4 plus 3 over a plus 4, if you have a common denominator, you leave it alone, just write it down, and then you add the numerators. So you get 15 over a plus 4. Okay, let's try the next one. Again, you get common denominators, so you can make it one big fraction, and we're going to add the numerators. So x minus 3y plus x plus 5y. Then we're going to combine like terms. So we get 2x minus 3y plus 5y is plus 2y. And then you leave the denominator alone. And notice, we can factor the top, because you always want to see about reducing. So we get 2x plus y, x plus y, the x plus y is canceled, and our answer is 2. Okay. Now, how do you add if they're not common denominators? So we had something like, say, y over y squared minus y minus 20 minus 2 over y plus 4. So my first step is I'm going to factor the denominators. So I get factors of 20 that subtract to 1, so it's 5 and 4. Put in my signs. And I move that minus to the top there, just to keep track of it. Now the LCD is going to be y minus 5, y plus 4. So what I need to do to the first fraction is nothing, leave it alone. And then for the second fraction, I need to put in y plus 4. I mean, y minus 5. So you put it in bottom, put it in top, because we're multiplying. This is really multiplying by 1. This is 1, so we're not changing the fraction. We're just making it look different. Okay? So now once we've done that, we got our common denominator, y minus 5, y plus 4. We're going to distribute the negative 2. So we get y minus 2y plus 10. And then you combine like terms. So that's negative y plus 10 over y minus 5, y plus 4. And there you go. Okay, so to simplify a complex fraction, there's two techniques. One of them is you view that big fraction bar in the middle as the division symbol, and to divide, we just take the numerator. So x squared minus y squared divided by xy, and then we're going to change the division to times. So the big fraction bar in the middle is division, and then we take the fraction in the denominator and flip it over, because we're going to multiply by the reciprocal. And now it's just a regular multiplying one. And then we can factor the tops, the difference of squares. Cancel. Cancel the x minus y's. Cancel a y. And we're left with x plus y over x. And that's my answer. Okay, so that's one technique, is you take the top fraction divided by the bottom fraction. So you view it as a division symbol. And another way to do it is to multiply everything by the LCD of what I call the little fractions. So let me show you. Okay, so we're going to multiply by the LCD over the LCD of all the little fractions, meaning these are the little fractions. Okay, so the LCD for all those will be AB. So what I do is I'm going to take A over B minus B over A, 1 over A minus 1 over B, and I multiply the top and bottom by AB. If you want, you can think of it like this. And then we distribute it. So when we distribute it, we got a squared b over b, the b's cancel, and we get a squared. For the second term, we get ab squared over a, the a's cancel, so you get b squared. And then on the bottom, we distribute it, we get ab over a, the a's would cancel, so we get b. Distribute the next term, we get ab over b, b's cancel, so you get a. Then we want to see if we can reduce it, so it's a plus b, so you factor. And notice, b minus a is the same thing as a minus b, but with a negative taken out. So I switch it so I can cancel that. And then I can move the negative to the top, and I get negative a, negative b. Alright. Okay, so that concludes the review for rational expressions. Go to My Math Lab, do your work there, and I'll see you next time.